Oh man, guys, check it out, man. I gotta make another power supply video. I need help. I need. I really need help, man. I need a stress reliever, and I don't care if anyone watches or not. I can't believe over 30 people watched the other ones. Most hams these days aren't into electronics, you know? Um, Got a little show and tell there for you, boys and girls. As if there's any girls in the landfill. um, Little show and tell, shows and tells for you. And I got to clean up I've shitted out my workbench again. And under the shows and tells items, I got some notes. On a serious note, I got a note to show you. Yeah, hey, man, I need a stress reliever, man. 2 weeks ago, my Potomobile, my truck, I blew up the rear end in it. And dang, man, and it's not worth fixing. And and 4 days ago, I think now, my refrigerator died. So that cost me 1,500. Lost 300 worth of food. Today the power went out, and when it came back on, the furnace did not. It Power went out when it was running. It overheated, blew the high limit switch. Actually, that's not true. That's what I thought would have happened. Oddly, the draft-proof vacuum switch went bad. It has a micro switch on it, single pole, double throw, and the normally closed contact was infinity. It's bad. So I'm going to reposition things. I want to talk about some of the loose ends, more loose ends, and yeah, hang on. Yeah, before I park you on the tripod, I should mention, in case any of you good, kind subs or any other folks that have stumbled upon the landfill and climbed the heap, those are printer cartridges because, hang on, man. The cabinet for an E.H. Scott radio. Astounding. Pre-World War II. Only the very most well-heeled Americans could afford that at the time. Exceedingly rare. But I digress. For any of you good people that have sent me a QSL card, I had no way to print them, man. I had no color printer. Just a black and white laser printer here, man. So I finally got it out of the box, and yeah, I'm going to print some QSL cards. Hang on. Okay, check it out, man. Show and tell comes first. The shows and tells. That Newmar power supply has a bridge rectifier like this in it, right? Probably a little bit heavier duty than that, right? That's probably good for 10 amps of safe service. I'm not going to use that because years and years, actually a couple decades ago, truthfully, I built this. It's the same thing. It's a bridge rectifier with four, I forget if they're 60 or 80 amp diodes. That'll serve nicely as my bridge rectifier. We talked about crowbar overvolt protection. That's the device. I looked in my pile of nightmares, and I've got a few high current stud mount SCRs. And that's what I'm going to do. Crowbar the output terminals. What else? The only item last, I don't know if you've ever seen this in a power supply. I seriously doubt the linear. Well, I shouldn't say that. That big ass linear power supply that MFJ sells. I wouldn't mind having it, but this is a big, nasty inductor. These wires are heavy. Oh, I can't bend it. It goes. You know how a capacitor passes AC and blocks DC? An inductor is the opposite. You put this in series with the output terminal inside the unit, and it passes DC and bucks AC. It blocks AC. That is out of the power supply in a Fresenius Model 2008H kidney dialysis machine. So that's going to, okay, I'm going to pause you. I've got scrimmage. Hang it. Man, I thought I better show you now and get it over with. Because I'm going to try to set it up at the next shot. Sorry to scare you, man. That poor family in that farmhouse. Damn, man. Hang on. Okay, man. Now, first, no, please. Dang it, Bobby. Dang it, Bobby. Why dang it, Bobby? Because now everything was pretty much worked out in my head, right? I've got a beefy bridge rectifier. I'm just going to buy 2 new computer grade or whatever. I want quality caps. I want Vichy or not even Vichy. I want Nishikan and or Chemicon. Anyway, man. So not a problem. Now, Jesus, what in the hell am I going to do? In my head, now seeing that Newmar power supply, this is an LM723 chip, and somebody mentioned in the comment, make it adjustable. Yeah, that's what that Newmar is. It's it's got an internal voltage and current over current limiting pot. It does current limiting, and that's why I haven't used it. I tested that power supply a couple times, but the overcurrent limiting is erratic. Sometimes it'll go into shutdown at 5 amps, sometimes the 22 or whatever you set it at, So in my head, I was going to dispense with all that crap and just use a discrete driver. Man, you're talking about the transistor that's already in it and a few extra, few resistors and such, a Zener diode, and you're happy. and a pot. And again, you calibrate it for the voltage you want out, right? This and what it has is it has an internal voltage sensing, but you can break it out and use external voltage sensing, and that's why I'm bad. Do I use an LM723? Hell, it's already soldered on the board. And speaking of that, I can pull a Peter move, a Victor Kilo 3 Yankee Echo, VK3YE. I'll strip the board. I'll pirate the board, cut traces, and do what I have to do to adapt it to my own design. And it's already drilled and laid out for the cabs. Actually, wouldn't be a bad. But that's what I was going to do. I was going to go with a basic discrete driver, use the existing pass transistors. You'll see the collectors are all tied in parallel. The bases they have a resistor, but those resistors are all parallel. The emitters have a super low value ballast resistance in the leads, and then they're tied together. That allows them to behave a little bit independently of each other, and not be forced to behave like each other, like if you tied the emitters directly together. So, we talked before about the placement of this shunt resistor. I could put it here at the output, and at the cost of worse voltage regulation. Am I okay with it dropping from 13.8 to 12.8 under 20 amp load? Hell yeah, I'm okay with it. And so is my Yaesu. It's not the best, and it'd probably be less than that. I don't know what my shunt. There we go. I don't know what my shunt resistor value is. If it's 5 times less than that, then my voltage drop will only be 0.2 volts. Or I can put it here and compensate for it. With the only caveat that now you're introducing, remember, current flows in series. So the same current flowing here is the current flowing here, despite the fact that these are dissipating a lot of power at certain loads. And by the way, your pass transistors do not get hottest at full output typically. And that's because under full output, the voltage of these filter caps sags way down. And so these drop less voltage across them. And it more than makes up for the high load. Whew, man. I'm coming down off the little, my little manic phase, man. Starting to crash. So that was my intention. I don't care where I put it. I'm good with it either place. After all, if you put it here, it's going to be exceedingly accurate anyway. I don't care, man. It's an analog meter just to entertain my eyeballs more than anything. And yeah. And of course, if it ever overvolts for whatever reason, and your SCR fires, and this is in Syria, you're going to roast your meter. It'll go up in flames. But your rig will be saved, and I don't care where I put the shunt resistor and meter my current. I'm okay. I thought 3 or 4 resistors, no LM723. Dang it, Bobby. But then I realized, or do I use the chip that's on that board? I'm going to pirate the board anyway and start cutting traces and chomping parts off. Do I use it? Do I find a design that uses this chip? I don't like the Newmar design. I don't trust it, and I don't want it. But there's a billion designs out there using that chip. Do I find one? And make that board, that stripped board in there, into that circuit, and use a voltage sensing line tied right at the output terminal. When you do that, you set that for 13.8 volts. This is going to do whatever it has to achieve that, even despite this, with another caveat. As long as your filter, the voltage on your filter caps is at least, stays at least about 15.5 to 16 volts, because you can figure you'll drop about 0.7 on the base emitter and another tad bit on the ballast resistor. Let's call that a volt. And another base emitter drop minimum in your driver stage. You're looking at about 1.7 volts there, and you got to stay reasonably well above that for this driver to be able to maintain voltage. Whew. What else did I want to say, man? Shoot. That's about it. That's enough. And I thank you for watching this miserable dribble. I enjoyed it. I always end up, it's like when you're running a marathon, man, because I'm scared. And it leaves me with a I come down from the adrenaline rush. Now, you may notice I turned on my signal generator and my VTVM, both complements of Heathkit. I turned on both my LED display and my Nixie display frequency counter. I plugged in my isolation transformer with industrial digital voltmeter on the output. Why? Because I'm bummed out about all the money I've spent on my damn refrigerator and food, and I got a dead truck out there, and I got a dead furnace in my ham shack. It all makes me feel good, man. Oh, we forgot one. And we won't turn on the Heathkit capacitor checker, nor the power supply. It needs a dual section pot. It needs me to get off my ass and order parts. Hang on. In closing, from our good friend Al and that poor family in that farmhouse that's fallen prey to another damned UFO. Yeah, we'll focus. Let's watch the Nixie tubes. Let's watch the circuit zero out 73 guys. Thank you, Heathkit. Stay tuned for a genius idea I have regarding their factory. Be well, guys.